Hi, I'm Samrat Ray, and today I'm going to talk to you about how do you effectively prevent data exfiltration on Google Cloud Platform. So we'll talk about the various data exfiltration risks that pertain to public cloud platforms, and we'll talk about a methodical approach to thinking about those risks. And then we'll look at some of the controls that are available on Google Cloud Platform. And in particularly, we will focus on what do we do about multi-tenant public cloud services, right? And how do we control for exfiltration while we're able to still use things that make public cloud so powerful. A little bit about me. I'm a product manager for Google's security and privacy organization. Right? I primarily focus on service security and insider risk. I'm a product manager for one of the products that we'll go into depth in this session. So before we start with talking about mitigating data exfiltration risks, let's start with how do we define data exfiltration? Data exfiltration can be thought of as the unauthorized copying or transfer or access, right, of data from a source, right? It's very important to think about it as not just access, but a key verb over there is the copying and transfer of data. Those are key elements that you need to think about when you think of data exfiltration. So to expand that to a more technical level, right? What are the risks that you actually need to mitigate as part of your data exfiltration strategy, right? Think of the kind of risks that you can have. These are risks that can occur irrespective of a public cloud or not. So these are a generalized listing of risks. The first is you can have misconfigured access control policies. So in many cases, your access control is delegated to a large number of people. Sometimes you have fragmented systems that do access control. So you can have access control misconfigured policies either on the back end or on the client, which then overexposes the data to a larger number of people than who are not actually authorized to see the data. And this could include, for example, in the worst case scenario, making it accessible to everyone on the internet. The second is, even if you've got your access control policies correct and pinned down, a lot of web access today occurs through the use of identity tokens, right? Like your OAuth or JSON Web Tokens, also called JWT, right? And other forms of credentials, right? Like API keys, for example, right? All of these credentials can be stolen, right? Or be copied, right? From where they were secured. And then that can be then used to access data from an unauthorized client, right? So thus transferring or copying of data out of where you want it to be. The third and the fourth are sort of slightly different versions of effectively the same risk, which is the first two correspond to preventing access from unauthorized sources to some extent, right? The third and the fourth are actually harder to mitigate because in this particular scenario, you have either a malicious insider as a human or compromised code, which could be again, deployed by the human, the malicious insider, for example, or could be compromised in some other way, right? Effectively copying data to unauthorized destination. In the third and the fourth cases, the data is being accessed from an authorized client, from an authorized source, using an appropriate credential, right? So trying to protect access to the source does not help mitigate the risk for the third and fourth. You actually need to have a way to constrain the movement of data effectively. So let's now talk about what is a sort of a structured approach that you can take towards mitigating data exfiltration. The first thing to note is data exfiltration is an exercise in risk mitigation, right? You never can eliminate things like somebody taking a notepad, writing something down, and walking over, right? That's a whole different form of security that we'll be talking about here. In the context of software controls, it's about mitigating risk. And the primary risk that you would want to mitigate typically is broad access to data and broad copying of data across two unauthorized destinations, right? And as with any other risk mitigation exercise, our recommendation is that you think of data exfiltration, the controls associated with to mitigate these risks, to be a pervasive defense in depth approach, right? You need to have multiple controls in place to give you the most effective security against data exfiltration. So what are the control points, if you think about it from a very structured manner? What are the control points and the kind of controls that you would want over there? So the three places where you can place controls, right? At the source, at the client, right? And at the perimeter, right? Or the network edge, as you might call it. So at the source, clearly you can have access control on the source. And some of the risks, the way to mitigate risk there is to have implement the principle of least privilege, which is make sure that only those who are authorized to access the data have access to it, including programmatic clients as well, right? Make sure they can only access what they need to access, and whether they need to read or write, it's exactly those permissions that are granted to such clients. The second is ensure that access is granted on multiple factors. This is particularly important if you're granting access from the internet. You want to ensure that you don't just grant access based upon a single credential, but you have additional factors to further strengthen your sort of authentication before you grant access. Then again, at the source, you may want to ensure that the configuration is locked down of your resource so that you have central policies that can help you lock it down so that any delegated fine-grained permissions, if they have been misconfigured, that you can mitigate the risks. About the clients, you can do things like we have a tool called binary authorization, which allows you to determine that any code that is deployed on a client comes from an appropriate provenance, has been signed by the right authorized users. So you can ensure that only authorized code can run on the clients. You can do monitoring, so you can identify anomalous behavior of the client, right? And you can signal based upon that. You can decide to only grant access to things from devices that are well managed and are locked down, right? So those are the kind of things that you can do at the client level. At the network level, this is the classic approach that we have all been doing for many years, which is to have a well-managed and secured perimeter. So you can have ingress and egress sort of policies. Think of them as like firewall policies that you would have. So but very interestingly, we can provide tools to ensure that it's not just about your layer 3 entities that define the policies. You can have layer 7 entities. So for example, you can say which identities are authorized to access from which networks and from which clients as part of your ingress policies. Similarly, on the egress control, you can say what are authorized destination, irrespective of the identity that is being used to egress. This is very important. Like on the ingress side, we talk about the identity and the use of identity to sort of narrow down who you grant access to outside a perimeter. On the egress side, it's very important because of the kind of risks and the threat model that we talked about, is that you are actually egressing with a legitimate credential, right? So you want to actually have controls that are independent of the identity on the egress side. Now, having said all of these, right, and the defense in depth approach, I think it is important to understand that perimeter security for these particular risk pattern is a mandatory control, right? You can build the other defense in depth pieces. So we'll delve a lot more into how do you build effective perimeter security on a public cloud platform. So why is it mandatory? Why are the other controls not sufficient, right? Your source controls, which we talked about, address only ingress. Compromised clients or users with authorized credentials can still exfiltrate data, no matter how well you protect the source. There are legitimate reasons in many business scenarios, like to actually copy the data, right? You create a BigQuery materialized view from a GCS data source. That's a really legitimate use of why you would want to copy the data, and you don't want to prevent that from happening, right? Not all clients can be binary authorized, right? This is pertaining very specifically to containerized clients, which you can have immutable infrastructure around, and so on and so forth, right? Monitoring is after the fact. So if somebody can do bulk copying, monitoring does not help much. It helps if they're doing ongoing copying, you can prevent it, right, from further damage. But if they've just done a bulk copy, it's not very useful. The other area where there's some misperception out there, which I feel is like the role of beyond cop in this posture. So Beyond COP effectively is an ingress policy. It's a layer 7 ingress control that offers finer-grained control based upon who is the user. Are they coming from a managed device? Are they coming from the right network location, right? So it gives you and which endpoint and path and data are they trying to access, right? Which are all layer 7 sort of entities, right? This is a much stronger security guarantee than a classic layer 3 VPN, where all you do is check, oh, they have an RFC 1918 address, the client, and therefore I shall now not look at any other factor and just grant access based upon a credential, right? So it gives you stronger security on the ingress path. But it is not a substitute for a well-managed perimeter, right? You still need to control for egress, and you still need to control for clients that don't necessarily fit into your Beyond COP model all the time, right? Like your compute instances or some VMs that might be running some arbitrary software inside your network. So that's a generalized posture. I would like to drill down, given this is a vast topic and we can't go into depth into every one of these dimensions. I'd like to drill down on the concept of what you need to do about multi-tenant cloud services. Because these are things that, services that you have now started adopting as part of your cloud adoption. And they have a different threat model, right? And they present new risks, not all of which has been sort of thought through completely as you try and adopt cloud, right? A fundamental change in posture that you have as you move from on-prem to cloud is that your data on-prem, the broad access to data, was typically behind one or more firewalls, right? So you would narrow down the access to data using application logic, and maybe that's what you expose as an API or an endpoint or a web endpoint that's accessible from less secure network places, right? But broad access to data, the back end of your databases typically, was protected by one or more firewalls. As you move to cloud, you want to put your data in these powerful storage systems that, say, for example, Google Cloud offers, like storage or Google Cloud Storage or BigQuery. However, these systems now offer broad access to data, and they're accessible from the internet. So it's a very fundamental change in posture, right? Secondly, these services are multi-tenant, as in not every resource associated with this storage system is under your control or is managed by you. And that presents new risks. So let's look at some of what is the risk posture, or what are the risk models over here for multi-tenant services. So we talked about oversharing using IAM policies. That is consistent and not a new thing that is specific to multi-tenant services. The same thing about stolen identities, right? Again, it's not specific to multi-tenant services. But what's new here, really, is how data can be exfiltrated by a malicious insider or a compromised code. Because your typical firewall policies with egress policies, all you can say is that grant access to the Google APIs, or not grant access to the Google APIs. Once you grant access to the Google APIs using your egress policies, at that point, a given client can pretty much copy data to any resource, assuming that they have the appropriate read authority on the source, right? And your firewall policies actually do not prevent that. So any entity, whether from the internet or from within your network, if they have the right credential, can now copy data over to an unauthorized resource, either of the same service, right, or of a different service. So, and there are two paths through which they can move data. One is they can download the data to the client or the compute instance and then write it to a public endpoint, right, as an example. And there's no real credential checks, no identity checks that matter, right? The second thing is they can use the backend or service-to-service paths to write data between the two. So in this particular case, we're showing from one cloud storage bucket to another, right? And none of these paths are covered by your firewalls today. So these are new risks that are presented by multi-tenant cloud services. So the big question is, what can you do and what can we do together to help mitigate these risks? So this is the threat model that we had in mind when we introduced VPC Service Controls. So VPC Service Control is a policy to segment resources of multi-tenant GCP services in order for you to mitigate data exfiltration risks, right? And so effectively, by using VPC Service Controls, you can start leveraging these powerful multi-tenant services and our data processing capabilities while still retaining the security that you associate with the VPC or your private cloud, right? So if you think of a service, a multi-tenant service, there are 3 network paths associated with the service. And we have shown all the 3 here. The 3 are the network path from the internet to the resource, right? From your private network to the resource, right? That's the second path from your VPC network. And the third is between resources on the back end of the services themselves, right? So for example, BigQuery accessing the Google Cloud Storage to create a materialized view, or copying of data between 2 storage buckets, for example, represent the last pattern, right? And so each of these paths need to be controlled, right? These are the paths that are the network paths for access and for movement of data. So we want to control all the 3 paths. So when we talk about segmentation of policies, or segmentation of these resources, it means having controls along those 3 paths, right? And this is something we at Google have spent a lot of time and energy thinking about, like, what are the risks presented by these paths? And one of our conclusion has been, after talking to a number of customers and looking at the overall industry landscape, is there is actually a limited understanding of risks associated with these kind of services, mostly because a lot of us tend to ignore the service-to-service paths, which are actually the most high performance and high bandwidth ways of moving data out of your control, right? So most of us tend to think in classic L3 terms, right? What can I access from my network, right? And can I just restrict the access from a resource to my network? So these are both kind of either you're thinking only ingress control, which is like, what can I only restrain access to a network or to an IP range? Or you're thinking of egress in a limited sense, which is what can I access from my network, right? You're not thinking about egress more comprehensively, which is along all the 3 network paths. So here we, as Google, are thinking about all these paths and making it simple so that you can just set up a policy, and we take care of mitigating the risks across all the 3 paths once you set up the policy. Right. So we'll talk about how we do this next. So what the policy does is the object that you land up creating with this policy is what we call as a service perimeter, right? Think of the service perimeter similar to having your VPC firewalls and putting VMs inside, right? Instead of VMs, here you're adding resources of these multi-tenant services into the perimeter, right? You also land up adding your network, the VPC network into the perimeter, right? By doing so, there is a fairly simple semantic that is used to provide fairly comprehensive security for these services. The first of the semantic is that all access between 2 entities inside the perimeter is allowed, right? And access between entities that cross the perimeter boundary is prohibited, right? With that, we land up, and this applies to all the 3 network paths that I enumerated earlier, right? So as you can see here, but when you set up this perimeter by default, access to these resources from the internet are denied. So they effectively become private to your virtual network, right? Your VPC network. Second, from the virtual network itself, you cannot access things that are considered to be public or outside your VPC, including other resources of the multi-tenant services, right? Like a bucket that is outside the perimeter is an example that we show here. And we can also reason about which private network you want to grant access to. It's not just that we are blocking access from the internet, right? But which private network do you have access to? So for example, another compute instance on a different private network would not have access to the resources inside the perimeter. And lastly, you cannot use the service-to-service path. So there are egress controls to prevent you from, or any unauthorized user, any authorized user for that matter, but with malicious intent or code with malicious intent, from copying the data to an unauthorized resource that is outside the perimeter, right? And we are able to reason about this not just on a single service basis, right? So it's not like the policy says, oh, prevent copying between 2 GCS buckets, right, that are within and outside. We are able to reason about this across service types. So what we mean by that is you can have a flow, a data processing flow that goes, I'm going to read this data using data flow or data proc, write it to BigQuery, right? Or write it to another bucket. And when I write it to the second bucket, I want to raise a notification that is a pub/sub event, which I then would subscribe to, and then write it into a third GCS bucket. And we are able to take this entire complex flow and ensure that it is running inside a single perimeter. This makes it a very powerful and more comprehensive capability than anything that we have built before. And we believe that this is the right way to think about how you protect data with multi-tenant services. One of the key elements of how you gain access from a VM is we have a feature called private Google access. What that means is, using that feature, you can now connect to your GCP services without necessarily egressing to the internet from your network. Right? By configuring private Google access, you can access it along a private path, and your clients don't need public IPs, and they don't egress through your gateway. Right? So effectively, again, this is how you implement the private cloud posture when talking to these services. And we have now extended this to make that posture be available from your on-premises. So your on-premise clients itself, by using either a VPN or interconnect, can privately access these services. And you can make sure that for clients that are accessing highly sensitive data, that those network segments do not also simultaneously have internet-based access to the rest of Google APIs. Right? So in that way, you can create a posture that you typically had in your production network, which is very guarded internet access. One more feature, like there are cases where you do want to grant access from the internet. I want to use the BigQuery console. I really like it. I want to use Data Studio to access my BigQuery data. We just did a demo of Data Studio, and it's a powerful BI tool. Right? How do you then gain access? Because these UIs that are managed are actually on the internet. They're not accessible through your private path. So therefore, if you want to grant access from the internet, we allow access based upon, as I mentioned, upon both layer 3 entities, right? Like, for example, IP addresses, right? But also with an understanding of identity. So you can say this particular service account or robot account is allowed to access, or this user is allowed to access, right? You can even combine the two. So we have some customers of this who say, OK, my data scientists and data engineers have to go through the private path. Right? They won't grant access. But I, as a security admin, want to be able to configure this from wherever. It's a more trusted and a smaller set of people. So you can say these 3 users can access it from this IP range, which might be the NAT address range, the IP range of your NAT gateway, for example. Right? So this is the way you can combine both layer 7 as well as sort of layer 3 sort of attributes in order to grant access from outside the perimeter. One of the more advanced features, but we see a lot of our customers using it, is the concept of a perimeter bridge. There are many cases while you have implemented full segmentation. We all know that data is something that you want to effectively share, but in a restricted and constrained manner. So we implemented this notion of a perimeter bridge that allows you to share data while keeping certain data sets private, right, between 2 segments. So it allows you to, so in this particular example, let's say there is one of our customers actually has a constant feed coming in from the internet, which they collect on a pub/sub topic, which gets delivered on a pub/sub topic. They subscribe to the topic, and they write the data into a bucket. Then they take the data, export it to BigQuery, right, mix it with other private data within BigQuery, and then run analytics on it. And their security posture demanded that the private data remain private, that they never get directly exposed to the internet. Right? So if you created a perimeter and put an access level, like I described in my previous slide, on a single perimeter, then your BigQuery data is also accessible from that access level. So here's the way in which case you can significantly mitigate that risk. Only the pub/sub, in this particular case, is accessible from the internet, right? The pub/sub topic, so that you can write data to it, right? And the pub/sub data, if the DMZ perimeter, for whatever reason, there's no compute on it, right? So the chances of it getting compromised and the risks associated with that getting compromised are minimal. But even assuming if that were to somehow get compromised for whatever reason, it only has access to the GCS bucket on the private perimeter, right? It does not have access to the BigQuery dataset, right? And your BigQuery dataset can only be accessed by the compute running inside your private perimeter, but not by anything that's running in your DMZ perimeter. So this allows you to, as you can see, you can create pretty powerful patterns using this set of policy tools that we have enabled for you. The last thing to note is that VPC Service Controls is a centrally managed policy framework, right? Policy construct. As in, you will have organization-level users, right, who configure these. This allows you to set up a mandatory, get your mandatory controls in place, such that even as you delegate your IAM administration to the project owners or to the resource owners, right, you can ensure that things that you intended never to be exposed to the internet will never be exposed to the internet, even if it is completely opened up from an IAM perspective, right? So with that, so VPC Service Control, it's important to remember, is part of a broader network and perimeter security posture that you would like to implement as part of your deployment on GCP, right? So when accessing from the internet, you would typically have some kind of ingress control, and you'd protect the edge as part of your perimeter, right, when granting access into any of your VMs or containers, right? And two powerful capabilities that we do provide on our cloud. One is Cloud Armor, which is like a WAF and has DDoS protections baked into it, right? And the other is Identity-Aware Proxy. So some of the access level that I just talked about before, you can also reuse those access levels, including also adding things like device-based trust, and then those policies can be implemented using Identity-Aware Proxy to grant access to your compute instances, right? And then you can use your VPC firewalls and VPC service controls to establish and secure your perimeter. With that, I'd like to do a very short demonstration of the feature and how you configure it. And then we can talk a little bit about additional policies that we have in place. Can we shift? OK, great. Awesome. So the VPC Service Controls is available as part of the security section of the console. And you can see there are two relevant pieces here, VPC Service Control and Access Context Manager. So the VPC Service Controls area allows you to configure these perimeters and perimeter bridges that we talked about. And Access Context Manager is how you create this reusable sort of access levels, which describe the risk associated with the client when they're trying to access data. And you can then take these access levels and associate them with a service perimeter or with Identity-Aware Proxy as an example. So let's look at VPC Service Controls and what it looks like. So first, it's an organization-level construct. So as you can see, I don't have access to it within a project context. I need to get to the organization level in order to gain access to it. So I'm going to create so the way to create VPC Service Control is start by defining your perimeter object. So you create a new perimeter. And when you create a new perimeter, you can give it a name. So for example, prod perimeter, right? In this case, we're creating a regular perimeter, which is used to add. And the way you add resources is you simply add projects containing those resources, as well as projects that have the networks, right? So I'm just filtering it by some projects that I've created for the purposes of this demo, right? So I have got, for example, a BigQuery dataset, storage bucket in my storage. The compute is the one that has my network on it, right? So I take these three projects, and I said I want to add these three projects. So all resources now, all BigQuery and GCS resources now are, which were in these projects, are now subject to be controlled by this perimeter. But at this point, they're still not being controlled by the perimeter, right? You want to explicitly enumerate which services you want the perimeter to control. And the reason for that is sometimes there is some risk that you might want to take, and it might be needed in your business application to be able to cross the perimeter boundary using certain services like PubSub, for example. And you may not want to constrain PubSub. In other cases, you just might want to apply to everything that you have, right? So for the purposes of this demo, let's just select everything, right? Over here, the first 10 services. There are two additional services here, which is like the Kubernetes Engine API and Stackdriver logging API. Let's first do this, select this. We can add the 10 services. We can go back. We can also then go back and add the logging API, right? Because we might want to care about it. One of the things I want to point out is the way we are thinking about this from a posture perspective is that we're not just saying, hey, mitigate the risk from your GCS bucket in this particular case, right? And we are saying that if you are using Kubernetes Engine in order to access those buckets, you will necessarily also have access to the container registry, right? And it's not very useful to protect the GCS bucket, but not the registry. Because the same risk model that is used to sort of copy the data to another public bucket can be used to just write the data into a container and write it to a public registry. It's no different. So we have to think of this as a systemic problem than a service-specific problem. And that's what we're doing here, right? We're going to create this perimeter. So before I jump into and apply the perimeter, let's quickly look at what we can do from on-prem. So one of the things is this is my, the white desktop here is on my laptop, and it represents a client that's on the internet. So I'm running gsutil copy command, ls command, just to see if I can see the data in there. But as you can see, I can not just read it, I can actually cat it in some cases, and I'm able to see the contents of it as well, right? So I can easily download it at this point because I can access it. And if I can download it onto my internet-based device, I can then write it pretty much anywhere, including Box, et cetera, right? Good. We have now managed to log into this one. So the other thing that I can do, which is one of the things that is the most hardest things to sometimes control for, is something like this. I can copy it from a secure bucket to an attacker bucket, right? And I can do this with a single RPC command, right? And when I do this, that's it. And I've moved, in this particular case, a small amount of data, but you could easily imagine that this is a very high-performance way of moving large amounts of data out of your control, right? And it's this command, and since that other bucket is out of your control, there's no way for you to know where the data finally landed up after this call has been made, right? And that's a pretty significant risk. And it's not just because you can move large amounts of data, but because it's so trivial to do this. So now let's set up the perimeter, right? And so I save this. And we now have a perimeter in place that, let's go back and look at it. It now says these projects are inside the perimeter, right? So the compute instance will still have access to buckets inside the perimeter, but should not have access to buckets outside the perimeter and should not be able to copy the data outside the perimeter as well. So let's go back to the compute instance that's inside my perimeter, right? This is the compute instance that's inside my perimeter. So we did the copy, but instead of doing a copy, let's just check, do we have access to the data inside the perimeter, which we should, all right? And we do, right? Let's see if we have access to the data that's outside the bucket that's outside the perimeter. Can I, for example, just download the data into a JSON file on my desktop or server here and then write it out? And I don't have access to the external bucket anymore. So as you can see, we have controlled the path from your network to resources that are actually not inside the perimeter. And of course, there's the backend path. Like, hey, I can't access it directly, but can I go indirectly and then copy the data? And even that is now being denied, right? So you can no longer do this even across the perimeter boundary. And this is a very powerful egress control that controls for all your network paths. You can similarly achieve the same thing even on the ingress side from a service-to-service perspective. I'm not demoing it here, but an example is a BigQuery data set that is outside your perimeter can no longer access the bucket that's inside your perimeter, right? So you cannot export the data, pull it out, create a materialized view there, and it's able to reason about this across two completely different service types, right? GCS and BigQuery, or PubSub for that matter. You cannot raise an event, for example, using PubSub from a GCS bucket that contains, as part of the event, your sensitive data, and then subscribe to it from outside the perimeter, right? So we are looking at this from a systemic and platform-wide perspective. With that, that's the demo. So that's what VPC Service Controls provides for you. I wanted to touch upon a more sort of comprehensive set of controls that we have on Cloud Platform, in addition to VPC Service Control that helps you mitigate the risk. There are some cases where you may not be able to enforce a full perimeter security, right? And the only option you have is not a preventative approach, but a more of a monitoring detection approach, right? And for that, we have threat detection and behavioral analysis of your sort of clients, for example, and code running on your clients. And you can understand your data exfiltration risk because of how your activity has changed right? And that is shown up in a product that we have called Cloud Security Command Center, which we also launched recently, right? And so that gives you monitoring capabilities, right? So in certain cases where, let's say, a service is not supported or a particular client type is not supported with VPC Service Controls and you must use it, this gives you some mitigation as to whether there's unusual activity happening under those circumstances. There are additional controls on GCP, and of course, you have the VPC firewalls, right? Your layer 3 controls. We have another very interesting control that we have, which can be used for mitigating data exfiltration risks, but only for GKE deployments today, because it is based upon the concept that what you deploy is you authorize appropriately, and you know the provenance of it, so that you can trust the code that is being deployed, and you ensure that it never changes post-deployment, right? That's very hard to implement in a VM-based deployments typically, but you can make that, that statement can be true for containerized deployments. So binary authorization is a deployment time control, right? And particularly if you're using our build systems and source control systems, or even just the build systems, we are able to give you even more integrations, better integrations between them. Even if you didn't, and you just use binary authorization, you can at least guarantee that their signature verification occurs before code is deployed, right? So that helps mitigate risk. It's not a comprehensive mitigation, because in many cases, you need to access data as part of interactive analysis, in which case, the very nature of that interaction is to have arbitrary kind of client logic being applied all the time, right? And you cannot really use binary authorization or a heavyweight approval and signing process in order for you to do that, right? But it's a good control if you have got an ongoing access using a very fixed pattern using clients, right? Then it's something that you can use. The other things that are typically used with VPC service controls all the time are organization policies for configuration control on the clients, right? As well as on the back end. So the first is compute engine. You want to ensure that no compute engine can come up with a public IP, right? In the space and those, in the case where they are trying to access data, sensitive data. So there is a org policy that prevents that from happening, right? So you would want to set that, right? So that now you can guarantee that all your egress is happening via your internet gateway, for example, right? And so that you can control for it. The next is on IAM, right? A very classic threat vector is that overgranting of privileges to everyone, to people outside the organization, and you're not aware of it. And you can prevent that from happening by, again, setting a configuration control using organization policies called domain-restricted sharing that ensures that only identities from your org can be allowed or be part of the policies, of the IAM policies for a particular resource. So in addition to VPC service controls, these are other sort of things that you can do to mitigate risk. And as I said at the start, right, like you really need to think of this as a defense in depth and a risk mitigation approach, right? And setting up a secure and well-managed perimeter is a fundamental part of that equation, right? Thinking about it is in terms of layer 7 ingress policies, like what we call Beyond Corp within Google, right? And versus just allowing arbitrary clients who are inside your RFC 1918 address to have access is another very significant part of this equation, right? So you configure the perimeter, you make sure that your perimeter is not weak because you are allowing portable devices that just join over your perimeter to have equivalent privileges to well-managed clients that are also inside your perimeter, right? The two are not the same, right? So you are able to distinguish between them as you gain access, as you grant access, and in particularly as you grant access from outside, from the internet. Then you do want to have appropriate configuration controls, right, to ensure that you can reduce the risk of misconfigured policies across all of these, across your resources. And VPC service control, from an ingress perspective, acts as a defense in depth, right? As in, the VPC service control checks are checked first before IAM is checked. Therefore, if you have disallowed access from a particular identity from the internet using VPC service control or from a particular network location, right? Then even if IAM grants such permissions, it will be disallowed by VPC service controls, right? So from an ingress perspective, it gives you defense in depth. It also provides egress controls, something that was missing, and it provides it along 2 dimensions, network to services and service to service access. And lastly, we continue to evolve this space, right? Providing more comprehensive access controls in terms of who can access and under what conditions, right? So we certainly encourage that you also have, you look at your audit logs and are able to reason about like any anomalous behavior in your audit logs and your access, both on the server side, right, as well as on the client. And you can leverage the Cloud Security Command Center for getting signals from various scanners that we have that detect these kind of behaviors, right? The last tool, which I have not mentioned here, is an open source tool called Forseti. So Forseti is something that scans the policies, right, across your organization, and you can build rules into it in order to understand what your policy posture looks like and whether they're compliant with how you would like it to be, right? So you can also use Forseti in addition to all of these, the open source tool, in addition to all of these, in order to better understand the security posture of your data.